Lesson 8.8, Solve Problems Involving Surface Area. In this lesson, we're going to learn about finding the area and surface area of two-dimensional composite shapes and three-dimensional prisms. Take a look at the solve and discuss it. Alea will paint the outside of a box with 3 different colors. Decide how she could paint the box. What is the total area that each color will cover? Well, in order to paint the outside of the box and know how much paint she needs to know the area of the surfaces that she will paint. In this case, the box is made up of different sized rectangles. The top and the bottom of the prism are identical, and they have dimensions 32 inches by 16 inches. Then we have the left and the right side, which you can't see in the picture. So the left side would be right here, and the right side would be right over here. And each of them has a dimension that is the same as one edge of the top, and that is the dimension 16. And the other dimension of the side is the height of that box, which is the 14. And then we have the front and the back. Oops, I'm going to move that over. Let me erase that and start again. And the front and back of the prism, here's the front, you can't see the back, have the same dimensions as well. This time it's 32 across and 14 high. To know how much paint she's going to need in order to cover that entire box, we're going to need to find the area of each face of that prism and then add those areas together. So do that and then come back and check those areas to see if you did it correctly. Here you can see the individual areas of each surface of that rectangular prism or box. To find the total surface area of that box, you need to add together the individual areas, or double each of them and then add them together, and you should get a final surface area of 2,368 square inches. That means when Alea goes to paint the box, she can do so with any combination of color she wants as long as she has enough paint to cover 2,368 square inches of surface. Next, let's take a look at finding the area of composite figures. This is similar to finding the surface area of a three-dimensional shape, in that a composite figure is made up of more than 2 geometric shapes. Or maybe I should say 2 or more geometric shapes. So this composite figure means that you can see a combination of geometric shapes in the picture, and if you find the area of each piece, you can put them back together to find the total area for a space. Look at example 1. A city planner wants all neighborhood parks to have more green space than non-green space. Does this park meet the requirements? So you'll notice that the green space is here where the tree lines are. So we need to know the area of the space where we already have the trees and the park-like areas. Once we have these areas, then we can also figure out if this is enough space that meets that requirements, that the green space is greater than the non-green space. So take a look at what they did in the picture. They took this diagram and they simplified it right over here. And they made a sketch of it and labeled the dimensions. So let's go back up to the picture at the top of the screen and let's take a look at how they split this into those spaces. So you'll notice that rectangle A stretches this way across here. And actually, let me use blue to do that. Maybe that'll be easier to see. And you can see that this space right here that I'm shading in blue is represented in rectangle A. Now, this blue rectangle has a height of 14. We can see that because it's also on the right side of the figure. And it has a length going across here. If you look, the dimension is 12 to this space. So this right here is 12. Across here is 12, and the total here is 24, which means 12 and 12 make 24. So this right here is 24 feet. Okay, next you have rectangle B, which is this one right here. That's where they cut that one off. That's a skinny one. And you'll notice that the distance that they've got labeled on the left side says 35 feet here, but then going across here, this is 24. So what's the difference between 35 and 24? That's the 11 feet that you see here in the picture. Okay, so this is rectangle B. And then last, you have triangle C that they've split this into. That's this piece right here. And triangle C has dimensions of 24 feet across, and then this is also 24, the side that it shares with rectangle B. Okay, then last, they take and they split up the green space. So right here we have the green space rectangle, and then we have a green space triangle here. And then we also have this box up here in the corner. So all of the dimensions from the figure that you see right here in this first step come from the original diagram. Okay, so I'm going to erase all this work that I've done on that diagram because I want you to be able to see, there we go. I want you to be able to see that diagram and then the dimensions with it. Okay, so next thing that you need to do is find the area of each of the non-green spaces, which are the blue rectangles and the blue triangle. So the area of rectangle A is 14 by 24. Okay, so this is 14 by 24, or 336. For rectangle B, you have 11 by 24, and 11 by 24 is 264. And then for triangle C, you have dimension height of 24, but remember for triangles you have to take half of the length times the width, so it's half of 24 times 24, which is 288. So the non-green space has a grand total area of 888 square feet. That's the blue areas that you see in our sketch. Okay, the blue areas up in the diagram, if you're wanting a comparison, is this space here, where the roads and the sidewalks are. Okay, so now we're going to try to determine if we have more green space than we have of the non-green space. So let's go to the next step here, and we're going to find the area of the green space. So the area of the entire park is what they're looking at here. That's the entire rectangular figure, okay? Had a total distance across the top here. Remember, 24 plus 12. So this dimension here is 36. And then the distance here along the side, you had a 14. You had 11, and then you had 24. So this entire distance across, or I'm sorry, along that side for that rectangle is 49. So these two dimensions will find the area of the entire park, 36 by 49, which is equal to 1,764, and that is in square feet. Okay, if that is the area of the whole park, then I can subtract out the non-green area, and what's left is the green space, which is 876 square feet. Okay, the park does not meet the requirements since the non-green space is greater than the green areas. Now let's complete the triad. The triad is going to be similar to some work that you're going to see on your homework assignment that goes along with lesson 8.8. This diagram shows the area of a room to be carpeted. What will be the area of the new carpet? So you can see right now that they've already split this into two spaces. So we have space that they're labeling A, which is a rectangle, and the dimensions of that rectangle are 5 by 6. So the area of the space labeled A is a 5 by 6 or 30 square inch space. For part B, we have a triangle. Now we have to do some inferring here, okay? The height of that triangle is the 6 right here, okay? But what is the measure of this base part? Well, the whole distance across is 9. The distance across the rectangle part is 5, which means this piece right here has to be 4, because the 5 from the top and the 4 here have to total 9 inches all the way across that figure. So for part B, we need to find the area of the triangle. Remember that area of a triangle is 1/2 times the base times the height. And half of 4 times 6 is 12 square inches. So the total area is 30 plus 12, or 42 square inches. Now, one of the things that you might need to write down are some helpful hints about area. So for a rectangle, remember that the area is simply a length times a width. But the area of a triangle is always 1/2 times the base times the height. Okay, remember your height is how tall is that triangle. Now let's try example 2. Solve surface area problems. Gavin constructed a model building and wants to cover the outside with paper. How much paper will he need to cover the entire model? So this is similar to wrapping a package. We need to use an exact amount of paper to cover the outside of that figure. So we're going to be finding the area of each piece of that figure and then having to add those areas together. So step 1 has us taking a look at each face on that model. So you'll notice that, first of all, the roof and the sides and the bottom are all going to be measured according to the dimensions on the shape. Okay, so the roof has one measure of 10 centimeters and the other measure is going across, that's this piece right here, that's 24, but this is 10, okay? Then we have 2 pieces along the roof. So the 2 pieces along the roof are seen here in step 2. So these are the 2 roof rectangles. Okay, the bottom, the front, and the back of this model here all measure 24 centimeters by 12 centimeters. Okay, so the bottom is 24 by 12 this way, and the sides are 24 going across and 12 high. So you have 3 pieces 1, 2, 3 in the picture, these 3 pieces that are all 24 by 12, which are 288 each. Okay. Then we have the sides that are composed of a triangle and a square. Okay. So we have the square, which is the 12 by 12. So 12 by 12 is the square. And then you have the triangle that is 1/2 times the 12 times the height, and the height of this triangle is not 10, okay? The height is the difference between the 12 centimeters tall for the front of that building, or the side of that building, and the total height of the entire figure, which is 20. So what's 12 take away 20? That's going to be 8. So when you do this multiplication here, you get half of 12 times 8, which is 48. Okay, and you have 2 of those parts. Okay, so this is the triangle piece. And then the 144 times 2, these are the square pieces. Okay, for a total area of paper to cover that model of 1,728 square centimeters. So when you're finding surface area of any three-dimensional figure, or if you're trying to find the area of a composite shape, find the area of the individual pieces that make up that figure and then add those pieces back together. Now let's talk through example 3. This is a very practical problem that you will run into. To solve a mathematical problem involving surface area, we need to think critically about the figure itself. First of all, I see a shape over here in this example that looks similar to like the sketch or a model of a house. Okay, you see the triangular roof line, and then you see a box, so to speak, on the bottom. What you don't see is the base of that triangular roof line, because it's on the inside, it's inside that figure. So that is not going to be included when we're calculating area. The same thing goes for the bottom of that figure, the box, the 6 by 6 by 6 inch box, which you see over here in step 1, okay? And the bottom of that figure here is inside the shape. That's the piece that sits on top of where the triangle roof is and is not included in that area. So when we find the area of this three-dimensional shape here, what we need to remember is we have a front and a back, a left and a right side, and a bottom. So we have 5 faces on that box that are going to be included in the surface area. And since each one of them is a 6 by 6 square, has an area of 36, then the area of the part that is the box shape is 180 square inches. Then when you look at the roof line, you have triangular shapes all the way around. Okay, so you've got 4 triangular shapes there and a square in the middle. But remember, you're not doing anything with that square because it is inside the figure. Okay, it's not showing and would not be covered. So to find the area of each triangular face, we have half times the base, which is 6, times the height, which is 4. So the area of each of those is 12. Since you have 4 triangles, 1, 2, 3, 4, then you have 4 of those triangles. Each one has an area of 12. So you have a total area of 48 square inches. So add together your 2 separate areas, and the area of that composite shape is 228 inches squared. Now we're going to take a look at the triad. Hiromi is painting the front and back of a barn, only the front and the back. Okay, the front and the back can be seen here in the picture, and I'm outlining them right now. And the front and the back are identical. Each can of paint covers 32 square feet. The question is, how many cans of paint does Hiromi need to cover the entire front and back of the barn? Well, the first thing that we have to do is find the area. So I'm going to split the front of the barn into two parts. The bottom part is a rectangle, and that rectangle is 11 feet by 12 feet. So 11 feet by 12 feet would be the area of that figure. What is that area? Hopefully you got 132. Then let's take a look at the triangular piece. The triangular piece has a base of 12, like you see here in the picture. That's along the bottom side. It matches up with the that part of the rectangle. And then the height of that we have to infer from the picture. So the height of the entire barn is 15 minus the height of the rectangle, which is 11, leaves a height of 4 for the triangle. So each triangle has an area of 1/2 times 12 times 4. Okay, what is that equal to? Hopefully you got 24. Okay, and now what we have is we have two of these. So we have 2 times 132, because we have a front and a back of the barn, plus we have 2 of those triangular parts, which is 24, and we need to find the total area that he is going to paint. So 2 times 132 would be 264, plus 2 times 24, which is 48, equals a grand total of what amount that Hiromi is going to be painting in order to cover the front and back of the barn. 312 square feet. Now, that doesn't exactly answer the question, because the question says, how many cans of paint does he need to cover the front and back of the barn? Well, in this case, we need to take our answer, 312, and divide by the number of square feet that a can of paint will cover, which is 32 square feet. And when you divide that, you get 9 7/75 cans. Now, the last time I checked, nobody sells me 3/4 of a can of paint, and I'm certainly not going to buy 3/4 of a can of paint. So we need to round this to make a reasonable answer. In other words, Hiromi needs 10 cans of paint to cover the front and back of the barn.